maybe we can start. So let's start and then let's see this example data warehouse we have already seen a few times in this lecture, in this course. We have the basic fact table, traditional one. Here we have three. Can I have a little bit more silence, please? So we have here as traditional sales fact table. We have three foreign keys to the time dimension, and actually this nowadays we will rename it more date dimension. And then we have one for the order date key, one for the due date key, and another for the ship date key. We have in addition other dimensions here, the shipper of this product, the product itself, the employee that managed that order, the supplier of this product, and the customer that bought this product. And in addition, we have a shared geography dimension. This geography dimension is shared in a traditional one-to-many for the customer and supplier, but we have a many-to-many relationship. An employee has attached to several territories. So this is a many-to-many dimension that typically in a data warehouse we put it as a bridge table to represent the many-to-many relationship. So with this example we are going to see 15 queries. And why 15? And we tried at least to get one query for one particular class of queries. So this is the concept of class of queries is an important thing that I want you to understand. Can someone explain what is class of queries? So in this example it's for data warehousing, but the same applies for whatever application you will do. Why I'm talking about class of queries?
You want to categorize a similar kind of query, like all the queries related to
similar type of query. So if I say 15 class of queries, without even understanding the details, we will go into that, but look at the first query. Traditional joins here, traditional aggregation with a group by for a sum of those dimensions, and then traditional aggregation query without nothing fancy. If I say this, the next, what happened with the 6.2? Yeah, I have a problem here. I was supposed to have all the 16, the 17 queries in this data warehouse, so maybe I didn't get it right. I have it in the book nevertheless, so sorry for that. I will send the complete section here. So the idea is that if we compare the query, the first one and the other one, here without seeing, we have already need a more complex query, a CTE expression. In addition to that, look at this monthly sales compared with those of the previous year. So here we have comparing. So I need to compute in a single one monthly sales, and then this table I use it twice with a left outer join. Whether left or outer join, a full join, the idea is that we are comparing two values. As you can imagine, it's more complex than this one. So we are trying to identify categories of queries. If what will be a query of the same category, similar to this one, please read the definition 6.1. Total sales amount per customer year and product category. What will be a similar query in the same category?
Average sales per year, for example?
Average sales, so you simply pick three other combinations of other dimension, not customer, but employees. or not customer, but country of the customers. So the idea is that you need to identify for your application classes of queries. Yeah, you remember the 99 queries in DPCDS? There are definitely not 99 classes of queries. Probably there are variations of the same query with different kind of combinations of dimensions that you want to extract from your data warehouse. So the idea is that you need to identify among all the queries that will be addressed to the data warehouse, the classes of queries, and then instead of evaluating the complexity of these 99 queries, you only pick, I don't know, 20. Because most probably there will be not more than 20 classes of queries and then you focus on these 20 instead of doing again a variation and do the benchmarking for the same thing. The order of magnitude, whether you are asking for customers or for employees, yes, of course, there will be much more customers than employees. But on the millions of terabytes of data, millions of rows, terabytes of data, this variation is not significant. What is significant is here that you need to compute two values and then compare the previous year with the same month in this year with this month with the previous month in the previous month in the same. No, the same month in the previous year. Sorry. So you get the idea. Second example of class of queries: countries that account for top 50% of sales amount. This is a complex query. We will see how to deal it. Forget the SQL query. Suppose that your manager asks you to say countries that account for top 50% of sales amount. When I teach SQL, it's always, I'm doing that for 20 years, if not 30. I always say, if you are not able to write your query in paper, you have a full piece of paper like this, and you have all the values. You're not able to define by hand the values of how would you do it by hand. You are not able to do it in SQL. So let's begin thinking about that. That will be a nice exercise also. Let's put it in this. I have a table here. You define the values you have on a paper, according to what, and then you will explain me our pencil and finger algorithm. How would you do this in a page? If you want, if I ask my secretary to do this by hand. Question: countries that account for top 50% of sales amount. So we know that we have a country here that will be Belgium, another country will be France, etc. And we are.
Can you do it here like?
Yes, of course. So then I need to. Thank you for asking me. I was hesitating. I was not sure, but you were right to insist that. And then I need. Do I have paper? No. So we have countries that account for top 50% of sales amount. So we have a country and we have sales amount. So Belgium has 20, France was 15, USA have 35, and you get the idea. You have that in a piece of paper. And then my manager asked me countries that account for top 50% of sales amount. Which is the algorithm, finger and pen algorithm that you will use for computing by hand. Forget the SQL. For SQL we will go. SQL will be a transliterator of this finger and pencil algorithm.
So you take a sum of your sales amounts, find out what 50% of it is, and then anything that's more than that number.
Yes, but let's elaborate how would you do it. If I say this to Charlotte, she will not, this algorithm will not be enough, but you get the idea. So we have until, suppose that this is my last country, Spain. And I have, I don't know, 30. How do Charlotte will do that by hand?
We sum all the sales amount.
We have already supposed that all this is 200.
50% of this will be 100.
Sort by like higher sales to lower the countries, and like till the 50% we will accumulate these total sales.
Perfectly. So suppose that among all, I know this. I know that the 50% will be 100. So I need it in any case. These two values I need it in any case. Then I need to sort this, as you rightfully put. We need to order this. I mean, we can do that in Excel. So this is how would you do it in Excel if you don't have this function. So suppose that I invert this value. I have 15, I have 20, I have 35, etc. So this is already a good point. Then
We need
Do you order in ascending order or
It should
descending?
be
it should be ascending indeed.
and it should be I think descending, so
Descending, it should be.
so that the higher sales country will be on the top. So
Yeah.
because you need the top 50% of the
Yes.
sales.
50% of the over. Give me, so for example, my idea is suppose that here we have 100. So I need to basically, I'm asking 50% of the sales amount. So I need to accumulate a list of values that the percentage of all these countries will be at least 50%, or the minimum that just goes beyond the 50%.
Yeah.
okay, so for that we need descending, because with
Yeah.
then we will add 30 and you add the 35 one, like if you go bottom to top.
They're
And
talking about
Spain
doing
and
a
USA
year to
will be
date
done.
on sales.
Sorry?
They're talking about doing a year to date on sales.
I think suppose that my solution. I don't get exactly your solution, but for 2 minutes, play with me, and suppose that I really need to have. I will put here 100 to facilitate the computation. I will use this. And I don't know, I have Canada 40, like this. So given these values, what I want is to say how much 50 is with respect to 100. It will be 50%. That will be, of course, 20%. That will be 35%. That will be 44%. You get the idea? And then out of that, I will, in my way of doing manually. Maybe we can discuss your way of doing it manually. So I do this first in increasing order. I compute this, which is the percentage of this. This will be 15%, this will be 20, 35. I need to adapt this until the minimum value that I get 50 or a little bit more. So 35, 65, so I need these three values for saying these three countries account for the, but you are right, it should be on the other way around.
Descending order, yeah.
It should be the other way around. So.
Or you can change your query to say the bottom 50%.
Yeah, that's, you get the idea. But this is my algorithm. So now when we have it when you have your algorithm here, we can transpose it in SQL. We will see that immediately. One question: which business question? Suppose that instead of 50, we are saying, why do we managers need this kind of query?
We can focus on those countries where the sales are which countries are I mean, there may be like 2 or 3 countries which are accumulating 50% of the sale and rest are accumulating 50%. So only 3 countries are major where we can do more advertisement and more into the sales.
So the idea is to identify the most profitable countries or employers or whatever, and then focus on that, because I don't know, this is the same in banking. Normal people like you and me, unless I know you have a previous inheritance of something, normal people like you and me are not very profitable for the banks because we have small amounts of money and we are costing for we are not producing revenues for we are more having cost for the bank. So they need to target those 3 or 5% customers that really giving a lot of sales or margins to the bank, and then propose to these 3 or 4 or 5 customers special offers or sending publicity or whatever. So this is the kind of business request that with this kind of query we need. So again, another class of queries year to date. The complexity of these queries will be different. You get the idea? Another class of queries. Yes, so this is a different query. For each employee, total sales amount, number of cities, and number of states to which she is assigned. As you remember, I told you at the beginning, we have a many-to-many, it was too fast. I have a many-to-many relationship between employees and city. For this, exploiting for customers or suppliers, exploiting the geography hierarchy is easy. It's just following, you take a thread, each of these referential integrities is like pulling a rope, a single rope, it's easy. When you have this, it's a little bit more complex than pulling a single rope. Okay, so of course the query in this case is a little bit more complex. We have another example of query that is related to recursive, and then let me go explicitly to the book. Sorry about that. I will put the full set of slides soon, but for the moment we need to have it here in the book. This is DAX, and now SQL. So another complex query is this one. Personal sales amount made by an employee compared with the total sales made by herself and subordinates. You remember that here we have a recursive hierarchy. An employee has a supervisor, and he herself has another supervisor until the end of the hierarchy. So we have the big boss, which is called employee 1, then we have E2 and E3, and then E3 has other employees E4 and E5. And what I'm asking here is, for this employee, I want to compare his personal sales with the sales of all his subordinates in many levels. And then you can immediately see, comparing, for example, here, we have here E5, E6, and E7. For this one, I need to do all this. For this one, I only need to do all this. For the manager, of course, I need to do all the managers. So somehow, I can compare. This is an important thing. Someone can be very effective himself selling, but he can be a good or not as good manager to motivate the people behind him. So we are analyzing two different factors of capacities of an employee. So again, this is another example of a complex query. That's another class of category of queries. So now you understand the notion of categories. It's essential that in your application you identify the categories of queries, and then you reduce the size of the thing you need to analyze. Otherwise, you need to analyze the 99 queries. Okay? So for example, for your exercise, you can define how many of the 99 queries of the TPCDS were essential to monitor. Probably only 20 of them will be essential to monitor, and you will have less work. But until that time, we didn't have time to explore this concept. Now that you understand all the issues, now I'm ready to explain this concept. So let's go for the queries. First one is easy. Sorry. Total sales amount per customer, year, and product category. Very simple. You have sales, you have customer, you have the date because you need by year, product, and category. All the joints, we have 1, 2, 3, 4, 5. It should be at least 1, 2, 3, 4 joints. Group by the 3 attributes. And then the group by of the 3 attributes and the sum of sales. Very easy query. Traditional, the simplest query, OLAP query you can expect. Second one query. Yearly sales amount. Look at this. If only by reading, the complexity of this query is a little bit more. Look how many joints. Because probably we need to compare, and then comparing we need to put more elements in our joint, but nevertheless it's similar. Look at this example. Yearly sales amount for each pair of customer country and supplier country. Intuitively, which is the business objective of this query? Forget SQL. Give me a manager perspective.
To understand the market inside a specific country of our product.
Customer and supplier. What are we are trying to optimize here? Imagine
Not buy things abroad to import them to another country.
so
Optimize the supply chain.
the
Supply chain.
yeah, we need to optimize the supply chain. I have many most of the sales from Belgium are obtained from products producing in United States. Maybe we can look local providers, suppliers of this to minimize the cost of shipping. You get the idea? So this is an example for, a potential business perspective for that. Of course, we need the sales and we need to exploit, look at this, the customer hierarchy, geography hierarchy, and the supplier geography hierarchy. It is the same. For the moment, they are one-to-many, traditional one-to-many relationship between all of them. With 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at least nine joint conditions. Group by the one's country of the customer, country of the supplier, year, and then compare the sum. Get the average sales amount, the sum of the sales amount. Okay for this? Next one, this is the one I was mentioning. Monthly sale by customer state compare of the previous year. Traditional to compare values for 2 different months. Look at this example. This is also an interesting idea. that it's essential to put it into your SQL queries. The question I want to ask you from a business perspective, forget SQL. Again, I push you to always think business. What happened when we have, I don't know, for a particular month and a particular sales, we don't have a customer that bought something in this state for this month. You want to appear it in your query or not? Given the definition here. Monthly sales by customer state compared with the previous year.
Yes, you want to appear.
And then it will be a null value for this. Whether it was in the previous year or the current year, I need to even include these values in my output. When I need to do all these joins that we will see and obtain the null values, what operation I need?
Coalesce to replace by 0.
Yes, that's the second operation I need, but how do I need to appear the null value? Outer join. You get the idea? If you have put a normal join, all these countries and this month will disappear in my table. So somehow, look at this. I need to compute all the combinations of state and month, irrespective of there were sales or not. So look at this. In this table, there is no sales at all. And I need this table to be sure that all of them appear. So I get the customer, the city, the state, and then the year month, you remember, is the one that we have seen at the beginning. I have all combinations of all the months for my data warehouse. So this will make me all possible values for the state and month. And then for each of those now I have a join with the sales and verify that, no, here I have all the values for state and month that existed formally with the sales amount for the state and month. You get the idea? I have all the months independent of the sales. I have here all the sales and the state for which there was at least one value. And now I can have the combination of the two. Let me see where, look at this. I have the state month to be sure that all the state and month appear. This is in my left, and so I open the right. Left outer join have the same, if there are sales for that particular combination, I will put this value there. Again, look at this, I have a left outer join for the previous year. It may be the case that the previous year, the same month of the previous year, I don't have the sales amount. So it's essential that I have first, we need to open as less as possible. So we fix the number of values here. And then when we have this fixed, if they will have sales for the current, for this month, put it there. If we have sale for the same month 1 year before, put it there. Otherwise, put null values. And then as you rightfully put, probably I could be more, if you let me see, no, you did it better than me. Here I would put probably a coalesce to replace a null value with 0.
But in this case, as soon as you did this, if you have 2 years where you've made 0 sales, on the second year you drop that person, right? Because you're only comparing this year to last year.
Yeah.
So if there's 2 years where someone had 0 sales,
But
dropped.
somehow, let me try. Do I have it here open? Yes, probably. Let me go here.
Like I'm thinking of the edge case where in January the customer never stopped making purchases in January for whatever reason. They won't show up anymore.
Let me go Control A, Control B here. Let me copy here the remaining of the SQL query and see Control here. I just explain you here the sales and month. So what we will have here only the first table. I need to connect. I need to put on the right database. North Wind Data Warehouse, execute. So I have all the, look at this, I can order a little bit, but Alaska 216, and then this is my start table on which I can begin adding if I have sales to the right for the current month for this month, and then if I have sales for 7/2015. And if not, like all these values will appear. Get the idea? So essentially, this typically when we do normal queries, we are not used to do that. But for a manager report, it's essential. So we need to begin thinking in a manager's perspective to write our queries. Is there any question with regard this query? You get the, I will send you the full set of slides, you will analyze, but you get the idea. We need to start from a fixed number of months, and then we use left outer join to add potential sales after. Same idea for this monthly sales growth per product, that is total sales product compared of the previous month. Same idea. Now I take here in this first, that will be all the values that will appear. The number of rows that will appear in my answer will be this. We have a product name, year, month number, month name, previous month year, and previous month number. You remember the view that we defined at the beginning. So if I put this into my SQL table, my SQL database, let me go here. I need a mouse, it will be faster, Control C. Here, no, this one. Control A, Control V. Look at this, we are already having, it's not perfect, this is a very small database. I did it with a view, probably with a view is not enough. I need to do it in a table. But basically this is the idea. I have the product name, year and month, name, and year and month 1 year before. And here, you remember, this is the lag function. Lag function is giving me, there were no previous sales. There is no previous month in this. Out of that, then I compute the same principle. The sales and sales for this product and month now from the sales table. Then do here I look, Nicole, I use the coalesce. I need to do the left outer join, and if there is a null value, I replace it by a 0. And the sales growth is I take the value if there is for the current month. If there is value, I take it for the 1 year before, and then do the minus to put the growth. Top three best-selling employees. So here it's easy. We have the sales and the employee table. I do the join, group by first name and last name. I just compute the first name plus in a single string the first name and last name as a single column. and then compute the sum, and then do the top 3. So this is an easy one. What is usually more common is to do not the overall best 3, but the overall per product and year, for example, or per category. So what am I asking here? Given this product and year and this year, give me the best employee for this combination. So again, I need to basically do the same thing as the previous one: sales, employee, date, product, and then I say by year, and obtain the best employee. Compute for all employees the sum of this, and then here from this I just need to say, for this combination, give me the one that is the best from the previous table. Countries that account for the 50% amount, this one we already said, total sales, we computed here, total sales, then sales by country, so basically this row, and then cumulative sales by country, so I have here the window function to get for the same, give me order this as you rightfully put in descending order, and then you sum all the previous values. So here you will have one additional, let's put this in right order. So you will have, let's put it here, 30, 25, 20, 15, and then of course you have the right values here. 30%, this is too easy. Let's put it here, 20, 15, 10, and 5. So here 10 plus, so here you will have 20. Here you will have 35%, here you will have 45%, and suppose that this is 6. So here you have 51%. So basically you need to filter all this and then obtain this only as the answer. So this is what we do. Here we do all these columns here. And the filtering is down here where cumulative sales is less than the one here. So again, you can see this. If you can do it on your paper, you can, or on your Excel file like this, you can write it in SQL. Otherwise, don't even think about it. It took me quite a long time to understand how to do it. So SQL is no rocket science. You do it by hand, you are able to do it in SQL. Yes, so this is an interesting thing when we are an interesting query when we are analyzing two granularities. We are having by year granularity and month granularity. So total sales by year, and average monthly sales in this, how much of this month accounted for the average of the year. So the idea here, of course, you need to get the smallest granularity by month, aggregate by month, and then you group by year. And then, of course, among all the months, you can have the average of the month. You get the idea? So here, this is the way to work with two granularities at the same time. by month and by year, or by week and by month, or you get the idea. You need to go to the lowest granularity and in a CTE expression, and then have it on aggregate on the bigger granularity in the outer query.
So is a tool like Power BI not doing this at a SQL level? Like I'm thinking like this is great, but it's complicated. If I have a graphic user interface and Power BI can do it for me easily, why?
No, they are Power BI or reporting services ask you to write this query. It is not here, but I don't have it. But Power BI asks you to write this query. I show you Power file.
I guess do they end up translating? Because like I've worked with Power BI before, and it's all graphic user. Do they translate what I'm doing graphically into SQL for me, and it may just not be very efficient SQL?
No, the issue is that you need to write it here. When you as a IT person designed implemented the report that the Power BI manager asked you, you need to do this. You need to provide the SQL queries.
Okay.
And I had a very hard time to do this in DAX. DAX is an horrible language, but this is my personal opinion. I need to add a former PhD student to work with me during the weekend to help me to do silly things. He's working on a company, he's doing that for on a day-by-day basis. And the simple thing, give me the last, look at this, WACAS, from WACAS definition. So this is, he needs to invest half an hour or 1 hour for just saying, give me the last date of the last order in DAX. I tried half a day. I'm not an expert in DAX, he's more expert than me. I tried half a day, and look how silly it is to compute the last date of the last order date of my database. Because the problem in DAX is that you have context. And context in DAX means this. The context in DAX means this. The context in DAX is this. And then your DAX query is dynamic depending on I have to quickly before it stops. Let me go here. Yes. Here. Okay. So the problem with DAX is that it's supposedly to be easy, since the DAX language takes into account in which context. So for when the context is the one Microsoft thing will be the basic context. It's easy, but when you want to escape from the context that the default context that Microsoft decided that this is in the average case, then you have a lot of problems, and then I need to ask an expert in DAX to do this silly thing. But again, the idea is the same. Once you have defined this in my tabular model, let's go here for the tabular model. Tabular model is there, here is the tabular model. So I need to put this. This is my definition in my tabular model, and then I can use it in my, look at this, it is called last month sales, and then if I open my last month sales, I'm using the percentage, so you get the idea. So I just pick all my measures that are here, I can use it in Power BI. But if I have a new measure, I need to go to the schema of the data warehouse in tabular model and provide me the right value for doing that. So Power BI, it's a very nice tool, much dynamic, etc. But you need to have the full queries already prepared in DAX or in SQL. And this is why it's essential that you are able to write the queries I'm showing you here, these kind of queries are essential. You need to be able to do that either in SQL, in query, in MDX or in DAX. So in the new version of the book, in the previous edition we have DAX and MDX, and in the new version I have added a DAX query for the same set of queries. Okay? So let me see, it's already almost there. We can we finish the 5 more tomorrow, and tomorrow I will print for another example database, either in paper. You can do it in paper. I will also give it in the same database in SQL, and then you can try it in SQL. It's up to you. For me, SQL in paper or in with PostgreSQL is it's more efficient, of course, more practical. If you do it by doing by hand, is predictable. My way of saying DAX is not predictable. It's impossible to understand how all these contexts put into place. SQL is predictable. You can do it in paper, you can do it in SQL, in the same thing. Yes?
Why don't they use SQL for this?
I mean, you can address this with Power BI. Instead of tackling the tabular model of the database, I can tackle the relational one, and in that case I can put my SQL queries on DAX. I was just trying as an exercise to learn DAX and be able to compare the two languages. But you can do the same in SQL, using Power BI or reporting services or Tableau or whatever other, or Grafana, which is the open source. All those accept SQL. So if you are able to manage to SQL, then you can do nice reporting. So see you tomorrow for the lab session for that, and that for me that would be all the topics that I wanted to cover. You are still having to finalize your TPCDI, so the next week, so you can continue easily take the hours for the lectures for complete your TPCDI exercise. One issue that happened, I mean, after the discussion with some of you last Friday, is that it was, according to some of you feedback, it was not clear that for TPCDI the minimal requirements is the historical. So if you are able to do the historical, this is the minimal requirement. If you do the incremental, these are bonus points. Of course, it is more complex to do the refreshing of the ETL, but if you don't have time and you need to optimize your time for the other projects, the minimal requirements, you succeed this project with reasonably good grades, if only doing the minimal requirements. Is it clear? So see you tomorrow. And then for those, we see you this afternoon.